This is the Chatterjee family from Kolkata. They decided to go for a trip. Now, they had two options. Either they could go to Cuttack from Kolkata or they could go to New Delhi from Kolkata. So if I ask you, for which city, that is for New Delhi or for Cuttack, will they have to travel a greater distance? Well, we already know that distance is equal to the length of the path taken. And as we can see here, that the length of the path from Kolkata to New Delhi, that is this path, is greater than the length of the path from Kolkata to Cuttack. So we say that the distance between Kolkata and New Delhi is greater than the distance between Kolkata and Cuttack. Since they had a longer vacation, they decided to go to New Delhi. And the distance between Kolkata and New Delhi is 1440 kilometers. Now, having decided on the place, they now wanted to decide their mode of transport. For that, they had three options. They could either go by a bus, or they could take a train, or they could take a plane. So now they had to decide between these three options. And how do they decide between these three options? That is, what is the difference between these three options? Let's see. In going from Kolkata to New Delhi, that is from K to D, the plane takes 2 hours. If they decide to go by train, then for covering the same distance, train takes 17 hours. And if you consider the bus, to cover the same distance between K and D, a bus would take 30 hours. So we see that the bus had taken 30 hours. So we conclude that to cover the same distance of 1440 kilometers, plane takes 2 hours, train takes 17 hours, and bus takes 30 hours. So what do we say? We say that plane is the fastest because it takes the least time. Train takes a higher time than plane, but a lesser time than bus. So train is faster than bus, but slower than plane. So in essence, what are we trying to say? We are trying to say that the transport which takes lesser number of hours is faster. So we can say that for the same distance, which was 1440 kilometers in our example, for the same distance, fastness is inversely proportional to time. So as time taken increases, fastness decreases. And the other way around. That is, as time taken decreases, fastness increases. This is true for the same distance. That is, if we keep the distance constant. Now let us see what happens if we take time to be the constant. We have plane, bus, and train here. And let us observe them in 1 hour. So in 1 hour, plane has traveled the maximum distance, train is in West Bengal, and the bus is still in Kolkata. Let us observe their movement in the 2nd hour. Now after 2 hours, we see that the plane has already reached New Delhi, train is in Jharkhand, whereas the bus is still in West Bengal. So we can say that plane has covered the maximum distance, or we can say that plane is the fastest. Train has covered a greater distance than bus, but a lesser distance than plane. So train is faster than bus but slower than plane, and the bus is the slowest. So what we are trying to say is, for the same time, that is, we took time to be constant, that is 2 hours. For the same time, fastness is directly proportional to the distance traveled. As distance traveled increases, fastness increases. As distance traveled decreases, fastness decreases. This is true if we keep time to be constant. So we have got these two proportionalities. First one, fastness is proportional to 1 by time. That is, fastness is inversely related to time for the same distance. Second one, fastness is directly proportional to distance traveled for the same time. And if we combine these two, we get fastness is proportional to distance divided by time. So fastness is proportional to distance by time. But how do we measure fastness? Well, the measure of fastness or slowness of motion is called speed. Speed is the distance traveled by a body in unit time. So the mathematical formula for speed is distance divided by time. So it gives us the distance traveled by a body in unit time. So what should be the units for measuring speed? We know that the standard unit for measuring distance is meters. And what is the standard unit for measuring time? It is seconds. So it is meters by seconds. So meters per second tells us how much is the distance traveled per second. So it is distance traveled per unit time. So the standard unit of speed is m by s, that is meters per second. So speed can be measured in kilometers per hour, miles per hour, centimeters per second, and the standard unit for speed, as we have already derived, is meters per second. It is denoted by m by s. Speed is a scalar quantity, as we had already seen, because distance is a scalar quantity, time is a scalar quantity, speed is a relation between distance and time, so speed is also a scalar quantity, and we require only magnitude to describe speed, no direction is required. So we have learned that speed is equal to distance by time. That is, speed is the rate of distance traveled. Now we have also learned that distance tells us how much a body has traveled, whereas displacement tells us how far the body has traveled. So do we have a corresponding term for displacement as well? What is the rate of change of displacement? Let's see. The measure of fastness with direction is called velocity. Velocity measures the rate of change in position, that is, the change in position per unit time. Its mathematical formula is given by change in position by time taken. What is the change in position? We know that change in position is equal to displacement. So velocity is equal to displacement by time taken. So this is the formula for velocity. Now since displacement is a vector quantity and velocity depends on displacement, so velocity is a vector quantity. The direction of velocity gives the direction of motion. So if we say that the velocity is in the east direction, that means the direction of motion is towards east. The standard unit for measuring velocity is meters per second, and it is denoted by m by s. Now let us solve a question. A car moves along a straight line towards east direction and it covers a distance of 108 kilometers in 3 hours. Find the speed of the car and the velocity of the car. So the car moves towards east, that is 108 kilometers towards east in 3 hours. What is the speed? Speed is equal to distance by time. Distance traveled is 108 kilometer. Time taken is 3 hours. So we divide it. We get 36. So speed is 36 kilometer per hour. That is, the car is moving 36 kilometers in 1 hour. What is the velocity? Well, the direction of motion is not changing. So the initial position is this, final position is this. Difference between the final and the initial position is 108 kilometers. So displacement is 108 kilometers towards east. And time taken is 3 hours. So velocity is 36 kilometers per hour towards east. So do you observe something here? Yes. We have speed as 36 km per hour and velocity as 36 km per hour towards east. So we can say that when the direction of motion does not change, speed is equal to velocity. Harry is walking on a straight line path at a speed of 2 meters per second in the north direction. After some time, he changes his direction to the east but continues to walk at 2 meters per second. What has changed? Well, we see that he was traveling at 2 meters per second. Again, later also he was traveling at 2 meters per second. So his speed remains constant. So speed hasn't changed. However, he changes his direction and velocity is magnitude plus direction. So even if the direction changes, we say that velocity has changed. So in this case, we say that the velocity of Harry has changed. So how can we say that velocity has changed? Well, velocity can change by either change in speed or change in direction or both. Alice goes to the park, which is 960 meters away from her house. She reaches there in 5 minutes and comes back in 3 minutes. What is the speed and velocity of Alice for the entire journey? Well, we know that speed is equal to distance by time. So distance traveled by Alice is 960 meters while going and 960 meters while coming back. So it is 960 plus 960 meters. And what is the time taken by Alice? The total time taken by Alice is 5 minutes while going and 3 minutes while coming back. That is 8 minutes. So it is 8 minutes. And when we convert it to seconds, we know 1 minute is equal to 60 seconds. So it is seconds. Note that it is very important to write these units because without these units, this expression is meaningless. Now let us calculate it. So we get 960 plus 960 as 1920 meters and 8 into 60 seconds. Cancelling out, we get this as 32, this is 4. So speed of Alice is 4 meters per second. Speed of Alice is 4 meters per second. What is the velocity of Alice? Velocity is displacement by time taken. What is displacement? Displacement is change in position. What is the change in position? Well, her initial position was her home. She went to park and then came back to the home. So home was her initial position as well as her final position. So displacement, which is change in position, is 0. So velocity is 0 by time taken. So this is equal to 0. So we see that velocity here is 0, whereas speed is 4 meters per second. So we conclude that velocity is 0 along a closed path. So when an object starts from a place, moves around and comes back to the same place, then because its displacement is 0, velocity is also 0. So along a closed path, velocity is always 0. Now speed tells us how fast the body is moving, whereas velocity tells us how fast its position is changing. So let us compare speed and velocity. Speed is the distance traveled by a body in unit time interval, whereas velocity is the displacement of a body in unit time interval. Speed is a scalar quantity. It does not require direction, whereas velocity is a vector quantity. It requires direction for its complete description. Speed is always positive, whereas velocity could be positive or negative depending upon the direction of motion. Speed is not 0 along a closed path because the object moves certain distance in certain amount of time. So speed cannot be 0 along a closed path. However, velocity is 0 along a closed path because displacement is 0 along a closed path.